Welcome to my video tutorial, and this is Kristen Foronas, your tutors for today's video. And our topic is all about on how to convert a coordinates from a point from rectangular to polar coordinate system and vice versa. But before we introduce to our topic, let me present to you the concept of our videos, which is to determine the difference between polar coordinate system and rectangular coordinate system, and also its formulas to use them and converting them from polar to coordinate system and vice versa. When we talk all about polar coordinates, it is a point in the plane is identified by a pair of number, which is the r and the theta. This number theta measures the angle between the positive x-axis and the ray that goes through the point. And this r is the radius, measures the distance from the origin to the point. This theta is the angle theta. And when we talk about the rectangular coordinate, it has a pair of x and y axis. And in this situation, you can differently see the difference between the polar coordinate and the rectangular coordinate system. And since we already know the difference between them, I will give you some examples after acing this one. Examples about illustrating polar coordinates and the rectangular coordinate system. Okay. First, I want to illustrate the example of rectangular coordinate system. As we all know, it has a pair of x and y axis. So if we have an x is equal to 2 and y is equal to 3, then plotting this one in the Cartesian plane, x 2, then y 3, this should be the plot of this. However, plotting the polar coordinate is different from this, since the number of days is r and theta, which is the plotting point of this one. So for example, if we have theta of pi 4 and our radius is 2, therefore plotting this one would be like this. 2 for our radius, then this is for our angle theta. This is the pi over 4. Therefore, since our radius is 2, then the plotting point should go like this. Our radius is 2, while our angle theta is pi over 4. And this is how we illustrate the difference between polar coordinate and rectangular coordinate system. Since you already have grasped understanding between the difference of polar coordinate system and rectangular coordinate system, you may wonder how to convert this polar coordinate to rectangular coordinate system and vice versa. But before we proceed to that, let me introduce to you the formula to be used in converting the polar to rectangular coordinate system. The formulas. So the formula for polar to rectangular, which is our theta, is tan inverse y over x, or tan -1 quantity of y over multiply to quantity y over x, while our r, the formula of this would be the square root of x squared plus y squared. And for this one, if we convert rectangular to polar, the formula would be like this. X is equal to r cos sine theta, while our y is equal to r sine theta. And these are the following formulas to be used on converting the problems. So please memorize or familiarize this formula, as in this activity we will have an example. First, let's have an example on converting the polar to rectangular coordinates. Rectangular, which is the given So on this example, we need to convert the polar to rectangular coordinate, and we have here the given r for 2 and theta for pi over 6. Therefore, the formula we need to use would be the x and y, since we need to convert the r and theta into the x and y axis. So the formula of x cos theta r and y is equal to r sine theta. And to do this, we just need to substitute the given r for 2 cosine, theta for pi over 6, and 2 cosine pi over 6, or 2 times cosine pi over 6 would be equal to square root of 3. And this is the square root of 3 is our x. And for our y, do the substitution of r, which is 2. Copy the sign. Then the theta, which is pi over 6. Then 2 sine multiplied pi over 6 would be 1. Therefore, the x is square root of 3 and our y is equal to 1. So, our rectangular of x and y is square root of 3 and 1. If we convert the r and theta of 2 and pi over 6, this would be the result. And next, we will have another example for this. And for second example, we need to convert from rectangular to a polar form. Polar form. Since our rectangular form is x and y, converting this, the result should be the r and theta. And r given for x and y is x for 1 and 2 for y. Since the problem given is that we need to convert the rectangular to polar form, therefore, we need to use the rectangular formula, which is r for x squared plus y squared, and our theta is for inverse tan y over x. And to do that, substitution of x, our x is 1 squared plus our y is 2. 1 squared equals 1, 2 squared 4. Therefore, our r is 5. And our theta our y is 2 and our x is 1. Then inverse tan, a quantity of 2 over 1 is equal to 63.43. Since this is an angle theta, therefore it should have a degree. And now, we have the results of our r and theta, which is our r is square root of 5 and our theta is 63.43 degree. And this is the polar form of this rectangular form of x and y, which is 1 and 2. And for our next example, I will give converting the rectangular form to polar form. Now let's proceed for our next example. Convert rectangular form to polar form. As we all know, our rectangular form is form of x and y. And the value of x is -1 and for our y is 2. Converting this rectangular form, the result should be the r and angle theta. Therefore, the formula we are going to use is square root of x squared plus y squared, and r theta is inverse tan quantity of y over x. First, we need to substitute the given of x and y. Or x is -1 and our y is 2. And the result of our r is square root of 5. But how did we come up this result square root of 5? It is by substituting the x and y, which is the x is -1 squared plus y 2, then 2 squared is equal to 4, and -1 times -1 squared is 1. So 1 plus 4 is equal to 5, therefore our result would be square root of 5. And for theta, we just need to substitute the value of y and the x, which is our y is 2 and our x is -1. Then do the operation. Inverse tan multiplied to quantity of 2 would be 51.76 degree. And this is our angle theta. Our r is square root of 5 and our theta is 51.76 degree. Then, to conclude this one, the rectangular form of x and y, -1 and 2, converting to polar, the r is equal to square root of 5 and our theta is equal to 51.76, which is correct. And for our last example, we just need to convert polar form to rectangular form. As what you have seen in this video, I have been using alternating the two formulas of rectangular to polar and polar to rectangular. And for our last example, as I've said, we just need to convert polar to rectangular. As I've said, the polar form is r and theta. And the value of r is -8 and the value of theta is 2 pi over 3. Converting this one, the result should be the value of x and y. Therefore, the formula we should use is x is equal to cosine theta and y is equal to r sine theta. Substitute the value of r and theta, which is negative 8 for r, and theta for 2 pi over 3. Then do the operation. Negative 8 multiplied to cosine quantity of 2 pi over 3, the x would be 4. And for our y, we also need to substitute the r and the theta. Since our r is negative 8, sine our theta is 2 pi over 3, then the y would be negative 4 square root of 3. And this is the result of converting polar to rectangular. Converting these r, theta, negative 8, and 2 pi over 3, the rectangular form would be the x is equal to 4 and y is equal to negative 4 square root of 3. I hope you have learned something from this video. And to sum up, the all about of this video, this formula will be using polar to rectangular. And this x is equal to r cos theta and y is equal to r sin theta. We will use this if the problem is asked to convert rectangular to polar. And that would be all. To sum up what we have discussed in our video tutorial on how to convert a coordinate of a point from rectangular to polar coordinate system and vice versa, we need to differentiate them. And their difference is that when we talk all about the polar coordinate system, it has an ordered pair of r, which is the radius, and theta, which is the angle theta, while the rectangular coordinate system has an ordered pair of x and y axis. That is their difference. But on converting them, we need to use the formulas. And the formula we have to use in order for us to convert rectangular to polar coordinate system is that the formula we should use is r is equal to square root of x squared plus y squared, while theta is inverse tan quantity of y over x. On the other hand, The formula we need to use on converting polar to rectangular coordinate system is x is equal to r cos theta and y is equal to r cosine theta. And that is their formulas. And that's all for today's video, and I hope you have learned something from it. From our topic, which is all about on how to convert the coordinate system of a point from rectangular to polar coordinate system and vice versa. Whenever you have a question, just comment in the comment section in our page. And also do not forget to click the notification bell and subscribe button in order for you to follow up my videos on this channel